What if I told you that astronomers were once convinced another planet existed right next to the blazing sun, and that on Mars they saw a whole network of irrigation canals built by an intelligent civilization? Today, we're embarking on a journey through the phantom worlds of our solar system. We will find the planets that never were, and uncover the mysteries that captivated the minds of the greatest scientists for decades. This is a story of great discoveries and even greater misconceptions. In the mid-19th century, the universe seemed almost completely understood. The great clockwork mechanism, wound by God and described by Newton's laws, ran without a hitch. The science of celestial mechanics had reached its zenith. Astronomers learned to predict the motion of planets with such precision that it seemed like a miracle. Every planet from Earth to the distant, recently discovered Uranus moved along its predetermined ellipse, as if on invisible celestial rails. Every single one, except for one. Mercury, the messenger of the gods, the fastest planet and the closest to the sun, held a secret that threatened the very foundations of all of Newtonian physics. It was a rebel in a perfect system. Astronomers, who had been observing it for decades, noticed an inexplicable anomaly. After completing its swift orbit around the sun, Mercury never returned to its exact starting point. Its orbit was slowly but relentlessly shifting in space. The closest point of this orbit to the sun, the so-called perihelion, was constantly shifting. The amount of this shift was microscopic, just 43 arcseconds per century. To picture just how small this is, imagine the face of a clock. A single minute on it is made up of 60 seconds. Now, imagine dividing the arc of just one of those seconds into another 60 parts. This tiny, almost unimaginable amount was the very anomaly that haunted scientists. But in the world of exact sciences, where perfect formulas are supposed to describe a perfect world, this discrepancy was more than just an annoying little detail. It was a crack in the foundation of all astronomy. How could it be explained? The gravitational influence of other planets, like Venus and Earth, was taken into account, but it only explained part of this shift. That left those 43 arcseconds, which seemed to mock the genius of Newton. And then, on January 2nd, 1860, in Paris, a man whose name was synonymous with the triumph of celestial mechanics stepped up to the podium before a meeting of the Academy of Sciences. His name was Urbain Le Verrier. He wasn't just an astronomer. He was a living genius, a scientific rock star of his time. Just 14 years earlier, in 1846, Le Verrier had accomplished what seemed impossible. By analyzing irregularities in the motion of the planet Uranus, he concluded that it was being affected by the gravity of another, unknown celestial body. He didn't just hypothesize its existence. He sat down at his desk and, using nothing but complex mathematical formulas, calculated the mass, orbit, and exact position of this mysterious planet X. He sent his calculations to the Berlin Observatory, and on the very first night of observation, in the exact spot in the sky Le Verrier had indicated, the 8th planet of the solar system was discovered, Neptune. It was a triumph of the human mind, the apotheosis of the predictive power of science. Le Verrier came to be known as the man who discovered a planet with the point of his pen. And now, this same man, with the same authority and confidence, took on the mystery of Mercury. His hypothesis was simple and elegant, and it mirrored his own previous triumph. If Mercury's orbit is distorted, it must be influenced by something else, something we can't see. Either, Le Verrier declared, there was another as yet unknown planet hiding between the Sun and Mercury, or there was an entire asteroid belt orbiting there. Their gravity, like an invisible hand, was nudging Mercury, causing its orbit to shift. The idea was logical, but how could it be proven? Observing objects in the immediate vicinity of the Sun is a nearly impossible task. Their light is completely lost in the dazzling glare of our star. Trying to point a telescope at that area of the sky during the day risked instantly damaging the expensive optics, and for the observer, it could mean irreversible vision loss. The only chance was to rely on very rare celestial events. Either wait for a total solar eclipse when the moon would block the sun for a few minutes, revealing nearby objects against the darkened sky, or get lucky and catch the moment when this hypothetical planet passed directly in front of the solar disk, becoming briefly visible as a small black dot. And then, as if on cue, it turned out that the proof might have already been found. A few months before his triumphant speech, Leverrier received a letter that changed everything. Its author was a humble country doctor and amateur astronomer named Edmund Lescarbault. In the letter, he reported that on March 26, 1859, while conducting his observations, he had witnessed an unusual phenomenon. A perfectly round, sharply defined dark spot was moving across the sun's disk. It didn't look like an ordinary sunspot. Those have irregular shapes and blurry edges. This body moved at a noticeable speed, and Lescarbault, being a diligent observer, meticulously measured and sketched its path for an hour and a quarter as it crossed nearly a fourth of the solar disk. He was even able to estimate the inclination of its orbit. For Leverrier, this letter was the missing piece of the puzzle, a confirmation of his brilliant hypothesis. He immediately went to see Lescarbault himself, subjected him to a thorough interrogation, checked his instruments and notes, and convinced himself of the observation's authenticity. Returning to Paris, he used the amateur astronomer's data to quickly calculate the new planet's approximate parameters. It orbited the Sun with a period of 19 days and 7 hours, and was 7 times closer to it than our Earth. Admittedly, the planet turned out to be too small for its gravity to fully account for Mercury's anomaly. But this didn't bother Leverrier. Perhaps Lescarbault had only seen the largest object in an entire asteroid belt, just as he had hypothesized. Leverrier was in love with his new idea. He gave the planet a name worthy of its fiery neighborhood, Vulcan, after the ancient Roman god of fire and forge. The scientific world erupted. A veritable Vulcan fever began, a great hunt for the elusive planet that would last for more than half a century. Astronomers all over the world waited for eclipses, spending hours staring at the blinding disk of the sun through darkened glass. In 1860, Leverrier himself organized an entire expedition of French astronomers to Spain to observe a total solar eclipse. Alas, the moon covered the sun, the sky grew dark, the stars appeared, but Vulcan was not among them. But that didn't stop the enthusiasts. Reports of sightings continued to pour in, creating even more confusion. Some astronomers saw spots, others saw nothing. In 1878, during an eclipse observed in the United States, an incident occurred that turned the search into a farce. The respected Professor James Watson claimed to have seen 2 intramercurial planets. At the exact same time, another famous American astronomer, Lewis Swift, was also observing the eclipse and also saw a planet, but he saw only one, and in a completely different location. So instead of one elusive Vulcan, astronomers suddenly had 4 hypothetical planets whose locations matched neither each other nor Leverrier's original calculations. Years went by. Eclipses came and went, but Vulcan was never caught. Gradually, the enthusiasm faded and skepticism grew. Most scientists came to the conclusion that the phantom planet most likely did not exist. But that left the main question unanswered. What was wrong with Mercury? The solution came from a world far removed from telescopes and observatories. It was born in the mind of a young patent clerk whose thought experiments would turn all conventional ideas about space, time, and gravity upside down. In 1916, Albert Einstein published his general theory of relativity. It stated that gravity is not a mysterious force acting at a distance, as Newton had believed. It is a consequence of the curvature of the very fabric of space-time by massive objects. Our Sun, like a heavy ball on a stretched sheet, warps this fabric, and the planets are forced to move along the resulting grooves. When Einstein applied his new, incredibly complex equations to the motion of Mercury, a miracle occurred. His theory predicted that the orbit of a planet revolving so close to the massive Sun in its powerful gravitational field must rotate. And the amount of this shift predicted by Einstein matched exactly with those same 43 arcseconds that had troubled astronomers for decades. The mystery was solved without any extra planets. The invisible planet Vulcan was no longer needed. The final nail in the coffin for this story came from the German astronomer Erwin Freundlich in 1929. During a total solar eclipse in Sumatra, he took a series of high-quality photographic plates, carefully capturing the entire vicinity of the Sun. Dozens of distant stars were visible on them, but there was no Vulcan, not even a tiny one. So what did Lescarbault, Watson, Swift, and dozens of other observers actually see? A mass hallucination? Unlikely. Today, it's believed that each of these sightings had its own mundane explanation. The humble Dr. Lescarbault most likely became the first person to accidentally spot a near-Earth asteroid crossing the Sun's disk. At that time, no one even suspected such bodies existed. Watson and Swift, obsessed with the desire to make a discovery during the brief, tense minutes of the eclipse, probably mistook ordinary stars near the Sun for new planets. Other observations could have simply been telescope defects, atmospheric disturbances, or comets passing close to the Sun. And so, the story of Vulcan came to an end. It was born from a tiny error in a great theory. For decades, it lived on in the calculations, debates, and imaginations of the best minds of its time. And it was erased from the celestial map by another, even greater theory. Vulcan will forever remain the most famous phantom planet. But it was far from the only phantom lurking in the depths of our solar system. In the architecture of the solar system, studied by astronomers for centuries, there was always one detail that disrupted the perfect harmony. A void, a vast, inexplicable, gaping space between the orbits of Mars and Jupiter. It had troubled even the great Johannes Kepler. In 1596, obsessed with finding divine geometry in the cosmos, he proposed that the law governing the orbits of the planets couldn't be complete without another celestial body hiding in that void. The thought of a lost planet hung in the air, but for nearly 2 centuries, it remained mere speculation. The push for a real hunt came from mathematics, or more accurately, what seemed to be a mathematical revelation. In 1766, German scientist Johann Daniel Titius discovered a remarkable pattern. He took a simple numerical series, 0, 3, 6, 12, 24, 48, 96, where each subsequent number, starting from the second, is double the previous one. Then he performed a simple operation. He added 4 to each number and divided the result by 10. This produced the sequence 0.4, 0.7, 1.6, 2.8, 5.2, 10.2. At first glance, it's just a set of numbers. But when Titius compared them to the known distances of the planets from the Sun, measured in astronomical units, where 1 unit is the distance from the Earth to the Sun, the correspondence was almost mystical. Mercury was at a distance of 0.4, Venus at 0.7, Earth at 1.0, and Mars at 1.6. Then came that mysterious gap at the 2.8 mark, and right after it, another perfect match. Jupiter at 5.2 and Saturn at 9.5, which was very close to the calculated 10.0. This pattern was made famous by the director of the Berlin Observatory, Johann Elert Bode, and has been known as the Titius-Bode law ever since. But this law didn't just describe the existing order, it screamed of a violation. At a distance of 400 million kilometers from the Sun, between Mars and Jupiter, there was supposed to be a planet, but it wasn't there. For a long time, astronomers treated this as a curious coincidence. But everything changed in 1781. English astronomer William Herschel accidentally discovered a new object beyond Saturn, which turned out to be the 7th planet of the solar system, Uranus. The scientific world was ecstatic, and someone remembered the old rule. Astronomers rushed to their calculations. The distance to Uranus, according to the Titius-Bode law, should have been 19.6 astronomical units. The actual measurement was 19.2. The margin of error was negligible. From that moment on, a simple coincidence transformed into a scientific law, a direct call to action. The search for the missing 5th planet became the main objective of European astronomy. For this purpose, the first international scientific collaboration in history was created, a group of 24 astronomers who, with a mix of pride and irony, called themselves the Himmelspolizei, the Celestial Police. They divided the zodiac into sectors and began a methodical, painstaking sweep of the heavens. But, as often happens, the great discovery was made not by a member of the project, but by a lone wolf. On the night of January 1st, 1801, Italian astronomer Giuseppe Piazzi, from the observatory in Palermo, noticed a faint little star that wasn't on his charts. The next night, he checked again. It had moved. It wasn't a star. This was it. The planet everyone had been looking for, moving in the exact orbit where it was supposed to be. The discovery was sensational. The new planet was named Ceres, after the ancient Roman goddess of agriculture. The mystery of the void seemed to be solved. But very soon, the joy turned to bewilderment. Just a year later, German astronomer Heinrich Olbers, one of the members of the Celestial Police, found another object in the same region, Pallas. And then came the discoveries of Juno and Vesta. By the mid-19th century, dozens of celestial bodies had been found there. It became clear this was not one large planet, it was a scattering of fragments. It was then that Heinrich Olbers, a man of his time, the Romantic era, when people were fascinated by the ruins of ancient civilizations and great catastrophes of the past, proposed a hypothesis that captured the imagination of an entire generation. He suggested that all these minor planets, which we now call asteroids, are the debris of a single large planet that perished in a terrible cataclysm. Olbers even allowed himself a romantic fantasy that this planet, like Earth, had been inhabited and that its own civilization might have existed there, destroyed along with its world. This hypothetical planet was given a name, Phaeton. The name was not chosen by chance. It alluded to the ancient Greek myth of Phaeton, the reckless son of the sun god Helios. The young man begged his father to let him drive his fiery chariot for just one day. But his weak hands could not control the fiery horses. The chariot veered off its course, drew too close to the earth, and began to burn everything alive. To save the world from destruction, the supreme god Zeus was forced to strike Phaeton down with a thunderbolt. The chariot shattered into pieces, and its driver plummeted to earth. The legend of a celestial catastrophe that nearly destroyed the world was a perfect fit for the story of an exploded planet. The idea was so beautiful that some enthusiasts took it even further, claiming the myth wasn't just an allegory, but a distorted memory of a real catastrophe witnessed by the ancient Greeks. But could this majestic and tragic story be true? Science demanded proof. The case was taken up by Urbain Le Verrier, the master of precise gravitational calculations. He understood that we could only see a small fraction of the asteroids, but their total mass could be weighed indirectly. Le Verrier reasoned that if a vast amount of matter truly existed between Mars and Jupiter, its collective gravity should affect the motion of neighboring Mars, slightly wobbling its orbit and creating tiny deviations from its calculated path. By knowing the magnitude of these deviations, one could calculate the mass of their source, that is, the total mass of all of Phaeton's fragments. The results of his calculations, published in the mid-19th century, were a cold shower for the hypothesis's supporters. The total mass of the asteroid belt, according to Le Verrier's calculations, could not exceed 1/4 of the mass of the Earth. This was already far too small for a full-fledged planet. Subsequent, more precise calculations by other scientists yielded smaller and smaller numbers. Today, we know that Le Verrier was actually being too generous in his estimates. The total mass of all known asteroids in the main belt is only about 4% of the mass of our moon. If you gathered them all together, you wouldn't even get a planet, but a dwarf Plutoid barely over 1,000 kilometers in diameter. Phaeton had shrunk to the size of a cosmic dwarf. Modern science offers a far more mundane, yet more plausible, explanation. The planet Phaeton never existed because it was never allowed to be born. The main culprit was its gigantic neighbor, Jupiter. During the formation of the solar system, when planetary embryos, planetesimals, were clumping together from dust and gas, Jupiter grew faster than all the rest. Its immense gravity acted like a cosmic bully. It either devoured the building materials in its vicinity or scattered them throughout the solar system. The material that could have coalesced into a proper fifth planet found itself in the gravitational influence zone of this giant. Jupiter simply prevented these fragments from uniting, leaving them to orbit forever as an asteroid belt, a belt of shattered dreams. It would seem the story should have ended there, but the legend of Phaeton proved too resilient. It moved from mainstream science into the realm of bold hypotheses and outright pseudoscience. For example, American researcher Charles Kowal suggested that Phaeton did exist and was destroyed by a collision with a giant asteroid 175 million years ago. According to this theory, its fragments are still bombarding the solar system, leaving giant scars on Mars, becoming moons of Jupiter and Saturn, and even forming their rings. Others went even further, creating a completely fantastical scenario. Supposedly, the two largest fragments of Phaeton turned into wandering comets. For millennia, they tore through the solar system, terrorizing ancient civilizations until one comet settled into a distant orbit, becoming the planet Pluto, and the second, after a series of catastrophic close encounters with Earth that caused biblical floods and earthquakes, settled into an orbit between Mercury and Earth, becoming the planet Venus. These theories, of course, do not stand up to any scientific scrutiny. Calculations show that the planet Phaeton never existed, but its ghost remains forever in the history of astronomy as a symbol of how a beautiful mathematical idea and a romantic legend can give birth to one of the most persistent scientific myths. And the name Phaeton has not disappeared from the maps. In 1983, it was given to a real but very small asteroid whose orbit, ironically, passes not through the main belt but very close to Earth. For millennia, Mars was a symbol of war and fury. To ancient cultures, its ominous red face, visible in the night sky to the naked eye, seemed to be stained with blood. The planet, named after the Roman god of war, carried an aura of danger and conflict. But in the late 19th century, in the age of steam, steel, and great engineering feats, the bloody Mars was suddenly transformed. It became a planet of hope, a planet of life, a planet of intelligence. And it all began with a single, misinterpreted Italian word. In 1877, the Great Opposition of Mars occurred, when the planet made its closest approach to Earth. Astronomers all over the world pointed their best telescopes at it. Among them was the director of the Milan Observatory, Giovanni Schiaparelli. He possessed not only a superb instrument, but also legendary, almost supernatural visual acuity. For hours, night after night, he stared at the orange disk, sketching the details of its surface. And he saw what no one before him had seen. On the surface of Mars, he discerned a complex network of thin, straight, dark lines that seemed to connect the larger dark areas known as Martian seas. Some lines stretched for thousands of kilometers, crossing the equator and reaching the polar caps. Being a cautious scientist, Schiaparelli called these structures by the Italian word canali. In Italian, this word can mean either natural formations, like channels or straits, or man-made structures, canals. Schiaparelli himself leaned toward the idea that they were geological formations, perhaps giant beds of dried-up rivers. He made no bold claims about life or civilizations, but when his work was translated into English, the word canali became the unambiguous canals, and that changed everything. The spark ignited by Schiaparelli turned into a wildfire in the imagination of one man, an American aristocrat, millionaire, and passionate space enthusiast named Percival Lowell. Hailing from a prominent Boston family, Lowell could have lived a life of leisure, but he was captured by a grand idea. He was fascinated by the thought of a Martian civilization and decided to dedicate his fortune and his life to proving its existence. His reasoning was as follows: if on Earth in the 19th century, humanity was building giant canals like the Suez and preparing to dig the Panama, why couldn't an older and wiser civilization on Mars do the same, but on a planetary scale? In 1894, using his own money, Lowell built the most modern observatory of its time in the Arizona desert at an altitude of over 2 kilometers. The location was not chosen by chance. The dry, thin air of Flagstaff provided ideal conditions for observation, minimizing distortions from Earth's atmosphere. The Lowell Observatory had a single purpose: the planet Mars. And Lowell saw, or rather, he saw what he desperately wanted to see. In the eyepiece of his telescope, he saw not just a few lines. He saw an entire planetary network, geometrically perfect, consisting of hundreds of perfectly straight canals that converged at points he called oases. Unlike the meandering rivers of Earth, the Martian canals were drawn as if with a ruler. For Lowell, this was irrefutable proof of their artificial origin. He created an entire theory, both grand and tragic. Mars, in his view, was an ancient, dying world. Its atmosphere had thinned, and almost all its water had evaporated, surviving only as icy polar caps. To survive, an ancient, wise, and unified Martian civilization undertook one last desperate attempt to save their planet. They built a colossal irrigation system that during the hot summer months when the polar caps partially melted, channeled precious water across the entire planet from the poles to the arid equatorial regions, irrigating fields in the oases. Only one obvious fact was troubling. To be visible from Earth, these canals would have to be several hundred kilometers wide. Who, in their right mind, would dig such wide trenches? But Lowell had an elegant answer for this too. He argued that we weren't seeing the canals themselves. They might be relatively narrow. What we were seeing were wide strips of vegetation, blooming furiously along their banks when water flowed through them. These green strips, contrasting sharply with the orange desert, created the lines he observed. Percival Lowell's books and lectures created a sensation. The idea of highly developed neighbors, reshaping the nature of an entire planet at will, captured the minds of people at the turn of the 20th century. The French astronomer Camille Flammarion wrote, "The human world of Mars has probably surpassed us in everything and has reached a high degree of perfection." People believed in Martians as fervently as some believe in UFOs today. This belief penetrated deep into the culture. In 1898, H.G. Wells, inspired by Lowell's ideas, wrote his famous novel, The War of the Worlds, in which, however, the wise Martians turned into ruthless invaders fleeing their dying world. Later would come Ray Bradbury's The Martian Chronicles and Alexei Tolstoy's Alita. It was from a comic strip about adventures on Mars in 1913 that the classic image of an alien, the little green man with antennae on his head, was born. The most dramatic manifestation of this belief was the mass panic that gripped the US on October 30th. A young director named Orson Welles produced a radio play of The War of the Worlds, styling it as a series of emergency news bulletins. Thousands of Americans who tuned in heard not a play, but a report, interrupted by anxious music about a giant cylinder crashing in New Jersey, about monsters with tentacles emerging from it, and their heat rays incinerating the army and police. People believed it. Chaos erupted. Thousands fled their homes in terror, clogging the roads, trying to get away. Some attempted suicide rather than fall into the hands of the invaders. Martians had transformed from a scientific hypothesis into a real threat. But while the public was fantasizing and panicking, skepticism was growing in the scientific community. Many astronomers with telescopes just as powerful as Lowell's stubbornly saw no canals at all. A great debate began. It turned out that the Martian canals were an optical illusion. The human brain is wired to see order in chaos. It instinctively connects unrelated dots, smudges, and dark areas into solid lines, especially when the observed object is at the very limit of visibility. Long hours at the eyepiece, eye strain, and an overwhelming desire to see, all of this created the perfect conditions for self-deception. As Stanislav Lem later wrote, "And yet, when you look at these magnificent maps by Schiaparelli, it's simply mind-boggling that he saw something that wasn't there. And what's strangest of all, others after him saw it too. It was some kind of psychological phenomenon." However, it's not that the astronomers saw nothing at all. Later, when detailed maps of Mars were compiled, it was discovered that some of the most prominent canals of Schiaparelli and Lowell did indeed correspond to real topographical features: Grand Canyons, chains of craters, valleys, and ridges. For example, the giant canyon system known today as Valles Marineris stretches for nearly 4,500 kilometers. Schiaparelli undoubtedly managed to see it as a single dark band. But this was not a man-made network, but separate, unconnected geological formations. By the 1930s, the conviction that there were no canals on Mars had become the dominant view in science. American astronomer Fred Whipple wrote, "The reader may form his own opinion. If he believes that intelligent beings could once have evolved on Mars, he has only to imagine that they continued to exist in a thin atmosphere, almost devoid of oxygen and water, on a planet where the nights are considerably colder than our Arctic winters." The final, crushing blow to Lowell's dream was delivered by the space age. In July 1965, the American probe Mariner 4 flew past Mars and transmitted to Earth the first ever close-up images of another planet. The whole world held its breath, waiting for these images. And what they saw was a bitter disappointment. The 22 grainy black and white photographs revealed a cold, dead, crater-strewn world. Mars looked more like the Moon than the Earth. No canals, no oases, not the slightest hint of the fruits of a great civilization. Nothing. The shock was so great that some voices called for Mars to be struck from the list of priority targets for space exploration. But fortunately, that didn't happen. The legend of the Martian canals died, but it had generated such a deep interest in the red planet that it could no longer be stopped. And for more than half a century now, we have been studying Mars with rovers. And the more we learn about it, the more complex and interesting it turns out to be. We didn't find ancient engineers there, but we did find traces of ancient rivers, lakes, and possibly even oceans. The myth of the canals is gone, but the dream that life might have once existed on Mars, and that maybe one day people will live there, that dream is alive and well to this day. Venus, named after the goddess of love and beauty, long remained the most mysterious of the terrestrial planets. Its surface is perpetually hidden by a dense, impenetrable veil of clouds that, like a shroud, conceals all its secrets. Unlike Mars, with its dark seas and polar caps, or Jupiter with its bands and famous Great Red Spot, Venus offered no discernible landmarks. This smooth, shining pearl of the sky gave astronomers not a single clue. They couldn't even determine how fast it rotated on its axis. For a long time, the prevailing theory was that Venus was tidally locked with the Sun, always keeping the same face towards it, condemning one hemisphere to eternal heat and the other to an eternal icy night. It wasn't until 1961, with the advent of powerful radio telescopes, that scientists managed to pierce the cloud veil. Radio waves, reflected off the solid surface, brought back shocking news. Venus does, in fact, rotate. But it rotates agonizingly slowly, as if reluctantly. A day on Venus lasts 243 Earth days. This is so slow that it leads to a stunning paradox. A year on Venus is shorter than a day. It manages to complete a full orbit around the Sun in 2025 Earth days. But in that same time, it doesn't even complete a single rotation on its own axis. This celestial beauty, swift in its dance around the star, turned out to be incredibly lazy and sluggish in its own rotation. And that wasn't its only oddity. All the planets in the solar system, except for it and Uranus, rotate in the same direction. Venus, however, rotates in the opposite, or retrograde, direction. On Venus, the Sun rises in the west and sets in the east. Why? What could have so drastically braked an entire planet and forced it to spin backward? One of the most intriguing hypotheses claims it was all the fault of its moon, a huge, massive moon that once orbited Venus. The powerful tidal forces generated by this giant acted as a massive brake, gradually slowing the planet's rotation and heating its interior to incredible temperatures. According to this theory, this didn't last long. After a few 100 million years, the gravitational interaction ejected this moon from Venus's orbit, sending it on its own journey through the solar system. And we may still know this former moon today. It is the planet Mercury. And after this catastrophe, Venus was left scorching hot, sluggish, and alone. Another, more modern hypothesis, proposed in 2006 by scientists at Caltech, paints an even more dramatic picture. According to it, Venus in the distant past, just like Earth, collided with a large celestial body. From the debris in its orbit, a moon was formed. But then a second catastrophe followed, another collision with a large object, which not only slowed Venus down, but also flipped its rotational axis, causing it to spin in the opposite direction. And for the moon, this was a death sentence. Whereas with normal rotation, moons, like our own, slowly drift away from their planet. With retrograde rotation, the opposite happens. The moon of Venus began to slowly spiral inward toward it, until, millions of years later, it crashed onto its surface, destroying itself and erasing almost all traces of the ancient cataclysms. Both of these hypotheses sound fantastic, but they perfectly explain the oddities of Venus. However, the most astonishing part of this story is that for 2 centuries, astronomers were convinced that Venus had a moon, and they observed it repeatedly. Its story began in 1672. The Italian astronomer Giovanni Domenico Cassini, director of the Paris Observatory and one of the greatest observers of his time, noticed a small crescent-shaped object near Venus that seemed to accompany it. Being an extremely cautious scientist, Cassini didn't trumpet the discovery, doubting what he had seen. But 14 years later, in 1686, he saw the mysterious object again, and this time recorded it in his observation log. By his estimates, it was a large moon, only a quarter of the mass of Venus itself. After Cassini, others began to see the moon of Venus as well. In 1740, it was observed by the English optician James Short. In 1759, by the German astronomer Andreas Meyer. In 1761, by the great mathematician Joseph Louis Lagrange himself, who was even able to determine that the moon's orbital plane was perpendicular to the ecliptic. The year 1761 became the moon of Venus's finest hour. That year, a very rare astronomical event occurred, the transit of Venus across the disk of the Sun. The attention of all the world's astronomers was fixed on the planet, and 5 different observers reported seeing its mysterious companion a total of 18 times. The most interesting report came from a German named Abraham Phaeton. he claimed that next to the large dark disk of Venus, he saw another, smaller dark spot moving across the Sun, its moon. However, the more sightings there were, the more confusion arose. Many respected astronomers, like the British Samuel Dunn, stubbornly saw nothing on that same day. The moon behaved like a ghost. It would appear to some with remarkable regularity, while eluding others. The debates intensified. In 1766, the director of the Vienna Observatory, Father Maximilian Hell, offered a simple and devastating explanation. He suggested that all the sightings were an optical illusion, an artifact of the telescope itself. The image of bright Venus, he argued, is so intense that it can reflect off the observer's retina and then be reflected a second time in the lenses of the eyepiece, creating a false ghost image next to the real planet. Simply put, the enthusiasts were seeing not a moon, but a reflection in their own eye. While some scoffed at this hypothesis, others continued with serious calculations. In 1777, the distinguished German scientist Johann Heinrich Lambert published detailed orbital parameters for the Moon in the Berlin Astronomical Yearbook. According to his calculations, it orbited Venus every 11 days and 3 hours at a distance roughly equal to the distance from the Earth to the Moon. The situation had reached a stalemate. The Belgian astronomer Jean-Charles Houzeau attempted to solve the mystery in 1884. He analyzed all documented cases of sightings and found a strange pattern in them. On average, the Moon was seen every 1080 days, or 2.96 years. Houzeau came up with a brilliant guess. What if it wasn't a moon at all? What if it was an independent, unknown planet whose orbit was positioned in such a way that it approached Venus and became visible next to it about once every 3 years? Houzeau even gave this planet a name, Neith, after the ancient Egyptian goddess of the hunt, whom mortals were not permitted to see. But just 3 years later, the Belgian Academy of Sciences put an end to this beautiful theory. A special commission conducted a meticulous investigation, re-examining every reported sighting of Neith. The verdict was final. In every case that could be verified, astronomers had mistaken ordinary stars for the Moon, which by sheer coincidence happened to be in the sky next to Venus. For example, James Short had actually seen an 8th magnitude star. Christian Horrebow had seen the star Theta Librae. A Dane named Rodekier was particularly distinguished, having mistaken 4 different stars in the constellations of Orion, Taurus, and Gemini for the moon of Venus on separate occasions. All of Lambert's complex calculations turned out to be a meaningless waste of time. After this complete debunking, the ghost seemed to have vanished forever. But it returned one last time. On August 13, 1892, the American astronomer Edward Emerson Barnard, a man with an impeccable reputation and eagle eyes who discovered the Horsehead Nebula, noticed a 7th magnitude object near Venus. He checked all the star charts. There shouldn't have been a single star in that spot. What he actually saw, we still don't know to this day. Maybe it was an unknown asteroid, or maybe it was the flare of a distant supernova. But strangely, no other astronomer noticed this flare. No one ever saw Neith again. The mystery of the moon of Venus turned out to be a story about the will to see, about self-deception and optical illusions. As it turns out, however, Venus does have a companion of sorts. Astronomers now know of the existence of asteroid 2002 VE68. It's a quasi-satellite. It doesn't orbit Venus, but its own orbit around the Sun is so synchronized with the Venusian one that it has remained its faithful, though unbound, fellow traveler for many centuries. For more than 2 decades now, ever since the first exoplanet was discovered, astronomers have been actively searching for a second Earth. They gaze out into distant stellar worlds, hoping to find a planet similar to ours, where the conditions for life could arise. But in the history of astronomy, there was another second Earth. We didn't have to look for this one trillions of kilometers away. According to the hypothesis, it was right nearby. Our neighbor, our mirror twin. The planet they called the anti-Earth, anti-Chthon, or counter-Earth. The idea was both simple and brilliant. This hypothetical planet, according to its proponents, orbited on the very same path as Earth and at the exact same speed. It was our eternal companion, but it was located at a point diametrically opposite to us, on the other side of the Sun. Moving in sync with Earth, it was always hidden from us by the dazzling disk of our star. For the astronomers of the past, this was the ultimate tantalizing mystery. A planet just 2 astronomical units away from us was more inaccessible than the most distant stars. Today, in the age of space exploration, when our probes and telescopes have peered into the farthest corners of the solar system, we know, of course, that no counter-Earth exists. But the idea of it lived a surprisingly long and rich life, originating not in science, but in philosophy and mysticism. It was first spoken of in the 5th century BC in ancient Greece. Its father is considered to be the philosopher Philolaus of Croton. Philolaus was no ordinary thinker. He was a Pythagorean, a follower of the great mathematician and mystic Pythagoras, who created a secret society, a kind of religious order that saw the foundation of the entire universe in numbers and their harmony. For the Pythagoreans, numbers were not just an abstraction, they possessed a real creative power. To them, the universe was a musical instrument, where the planets, moving in their orbits, created the music of the spheres, a divine harmony, inaudible to the ears of mere mortals. The model of the world that Philolaus described in his book on nature was radical and completely different from the accepted view. It was the first non-geocentric model in human history. At the center of his universe was not the Earth. There blazed a central fire, which he called the hearth of the universe, the house of Zeus, and the mother of the gods. Around this sacred flame, all the celestial bodies circled as if in a dance, and the Earth was just one of them, an ordinary planet completing an orbit around the center in a single day. But this is precisely where the problem arose. In Philolaus's model, we, the inhabitants of Earth, could never see this central fire. How was that possible? Philolaus explained it this way. We live on only one side of the Earth, the one that is always turned away from the central fire and towards outer space. Our hemisphere is illuminated and warmed only by reflected light. The sun in his system is not a source of light, but a giant glass mirror that captures and reflects the light and heat of the central fire onto us. The other side of the Earth, facing the center, is perpetually scorched and uninhabitable. It was in this bizarre cosmology that the counter-Earth, or anti-Chthon, was born. It revolved in an orbit between the Earth and the central fire. Moving in sync with our planet, it always remained invisible to us, completely obscured by the body of the Earth itself. So why did Philolaus need this invisible planet? There were 2 explanations. The first was mystical, tied to Pythagorean numerology. For them, the number 10, the decade, was a sacred, perfect number that encompassed the entire nature of numbers. But there were only 9 visible celestial bodies in their system: the sphere of fixed stars, the 5 planets, the Sun, the Moon, and the Earth itself. To achieve sacred harmony, to have exactly 10 participants in the cosmic choir, they simply invented a 10th body, the counter-Earth. As Aristotle later wrote, criticizing them, and where there were gaps, they tried to fill them in to make the system coherent. But there was a second, more physical explanation. If the massive Earth, composed of heavy elements, revolves not at the center of the world, but on its periphery, it would disrupt the balance and harmony of the entire system. To balance the universe, so that its center of mass coincided with its geometric center, the Pythagoreans placed another equally massive body on the opposite side of the central fire, our cosmic twin sister, the counter-Earth. Philolaus's system was too strange to gain widespread acceptance. Soon, the model of Aristotle and Ptolemy triumphed, in which the Earth firmly occupied its central and motionless place for 1,500 years. In this majestic geocentric picture of the world, there was simply no hiding place left for a twin planet. But the idea did not die. It was revived almost 2,000 years later, in the modern era, not in mysticism, but in the rigor of celestial mechanics. The French mathematician Joseph-Louis Lagrange, analyzing the gravitational interaction of 3 bodies, for example, the Sun, the Earth, and a third smaller body, made a fundamental discovery. He found that in such a system, there are 5 special points where the gravitational forces of the 2 large bodies and the centrifugal force balance each other out. Any object placed in one of these Lagrange points will remain stationary relative to the large bodies, moving along with them as a single unit. 2 of these points lie on the line connecting the Sun and the Earth. 2 more are located on Earth's orbit, leading and trailing it by 60 degrees. But the last 5th point, known today as L3, is located precisely where the ancient counter-Earth was supposed to be, on the other side of the Sun, in the same orbit as Earth. Theoretically, an unknown planet could exist at this point. Lagrange's calculations gave the ancient idea a new, mathematically flawless life. But theory is one thing, and reality is another. Lagrange's calculations were made for an idealized 3-body problem. In the real solar system, there are also Venus, Jupiter, Saturn. Their gravitational influence, though weak at such a distance, would constantly nudge a counter-Earth located at the L3 point. This point is not absolutely stable. Calculations show that gravitational perturbations from other planets would inevitably destabilize the orbit of a counter-Earth over a few million years. It would leave its cozy Lagrange point and, most likely, eventually collide with Earth. Today, scientists are certain that if a counter-Earth had formed at the same time as Earth, then some 4.5 billion years ago, at the dawn of the solar system, this cosmic kiss of death would have been unavoidable. We were saved by the fact that the probability of 2 identical planets forming in the same orbit is infinitesimally small. The ghost of counter-Earth, born in the mystical visions of the Pythagoreans and revived in the strict formulas of celestial mechanics, was finally dispelled with the very first space probe that peered behind the Sun. In the night sky, Earth has one faithful and unchanging companion, the Moon. She has inspired poets, governed the tides, and was the only celestial body whose face changed from day to day. But what if she is not alone? What if, next to her, invisible to most, orbits another, a second moon? This idea, which captivated the minds of astronomers and dreamers for nearly a century, spawned one of the strangest hunts for celestial bodies in history. The story began in 1846. Frédéric Petit, director of the observatory in the French city of Toulouse, made a sensational announcement. He reported that his staff, while observing the sky, had discovered another, extremely small satellite of Earth. Petit, after verifying their observations, enthusiastically set to work on the calculations. And the picture he painted was astonishing. According to his calculations, the second moon moved in a highly elliptical orbit, completing one revolution around the Earth in just 2 hours, 44 minutes and 59 seconds. At its farthest point, its apogee, it was 3,570 kilometers from Earth. But at its perigee, it came incredibly close to our planet, skimming just 11.4 kilometers above the surface. This was less a satellite and more a supersonic bolide, barely grazing the mountaintops. Carried away by his idea, Petit went further. He suggested that some of the then unexplained small deviations in the motion of our main moon could be explained by the gravitational influence of this tiny but very close planetoid. However, the scientific community met his discovery with an icy silence. His fellow astronomers simply ignored him. The calculations seemed too incredible, and the observations unreliable. Petit's discovery would have been forever buried in dusty archives if not for an intervention from literature. That intervention had a name: Jules Verne, the great science fiction writer whose novels inspired entire generations of scientists and inventors, read about Petit's hypothesis. And the idea fit perfectly into the plot of his new novel, Around the Moon, published in the book. 3 brave travelers fly to the moon in a giant projectile launched from a cannon. But due to the gravitational influence of an unexpectedly encountered asteroid, their ship doesn't crash on the moon, but instead enters into orbit around it, becoming an artificial satellite. The heroes find themselves trapped, doomed to circle in space forever. And then, when all hope is lost, they encounter a small celestial body on their path, the very same second moon. "Is it really possible?" exclaims one of the heroes, Michael Ardon. "Does the Earth have 2 moons?" "Yes, my friend," the expedition leader Barbicane replies, "although it is generally believed to have only one, but this second satellite is so small and its speed so great that the inhabitants of Earth cannot see it. The encounter with this body nearly leads to a collision, but instead, it changes the trajectory of their projectile, and it is eventually sent back to Earth, saving the heroes." Millions of people around the world read this thrilling novel. And for them, the second moon, discovered by the French astronomer Petit, became an indisputable scientific fact, immortalized in literature. The idea was brought back to life, and Petit found his followers. In 1898, a German amateur astronomer from Hamburg, Georg Waltemath, took it even further. He announced that he had discovered not one, but a whole system of tiny satellites of Earth. He even provided the exact parameters of one of them, the largest. According to him, the diameter of this second moon was about 700 kilometers. It orbited at a distance of 1,000,000 kilometers from Earth, completing one revolution in 1119 days. Waltemath even claimed that this moon was so bright that it was sometimes mistaken for a second sun. As proof, he cited the diaries of the American polar explorer Adolphus Greely, who in 1881 in Greenland had allegedly observed the solar disk for 10 days after the polar night had already begun. Waltemath was so sure of his discovery that he made a public prediction. On February 3 or 4, This announcement caused a stir. On February 4th, in the German town of Greifswald, the post office turned into a makeshift observatory. A good dozen enthusiasts, including the postmaster Mr. Ziegel, his family, and his colleagues, crowded around the windows, peering at the blinding sun through darkened glass. And, as they later claimed, they saw it. They observed some dark body that slowly, over the course of an hour, crossed the solar disk. The discovery seemed to be confirmed, but the triumph was short-lived. It soon became known that during that very same hour, two experienced astronomers in different parts of Europe were also observing the sun with professional telescopes. And they detected nothing but ordinary sunspots. Waltemath's discovery turned into an embarrassment, and the post office worker's observation became a classic example of mass self-deception. But even this didn't stop the search. In 1922, the renowned American astronomer William Pickering, though skeptical, fueled interest in the topic by calculating that a satellite of Earth just 3 meters in diameter would be visible to the naked eye. This meant that if we don't see anything, any other satellites must be even smaller. He called it a pastime for amateur astronomers, and the amateurs responded. A few years later, a German astronomical journal reported that a Mr. Spill had observed the transit of such a satellite across the disk of the Moon on May 24, 1926. But this discovery, like dozens of others, was never confirmed. The idea even penetrated into astrology. In 1918, the English astrologer Cephariel gave the hypothetical satellite the name Lilith, after the demoness from Sumerian mythology. He claimed that Lilith was a dark moon, a completely black body that is impossible to see, except for the rare moments when it passes in front of the sun. So, were all these people, Petit, Waltemath, Spill, hoaxers, or were they simply mistaken? Perhaps both, but there is a third, more scientific explanation. It's possible they really did see something. Modern astronomy knows that Earth can have temporary satellites. Sometimes, our planet's gravity captures small, passing asteroids or meteoroids. They might spend a few weeks or months in orbit around Earth, making a few revolutions before either flying off or burning up in the atmosphere. One such object, asteroid 2006, RH-120, was in Earth's orbit for nearly a year from 2006 to 2007, becoming our temporary second moon. It's very likely that astronomers of the past, unaware of this phenomenon, could have mistaken such a temporary object for a permanent satellite that then mysteriously disappeared, making it impossible to verify the discovery. There are also quasi-satellites, like the asteroid Krufny. It doesn't revolve around the Earth, but its own orbit around the Sun is so cleverly synchronized with Earth's that for centuries it has remained our cosmic companion, moving alongside us in a complex horseshoe-shaped path. So, although Earth does not have a second permanent moon as Jules Verne and Percival Lowell dreamed, its celestial neighborhood has turned out to be far more interesting and populated than we thought. Our planet is not so lonely in its dance around the sun, and from time to time it acquires fleeting companions, true mayfly moons. The story of Vulcan, Phaeton, and the second moons is not just a tale of mistakes. It's a story about how science works. It moves forward not only through brilliant insights, but also through bold hypotheses that, even when proven wrong, force us to look at the sky more closely and ask new, deeper questions. Thank you for joining us on this journey through the phantom worlds of the solar system. In the next part, We will leave the confines of our cosmic home and talk about how humanity imagined the entire universe, from a cozy world with Earth at its center to the brilliant and insane ideas that changed our worldview. Subscribe to the channel so you don't miss what's next. There are still many mysteries of the cosmos ahead.